afternoon, everybody. Oh, you can hear me. Okay, so I'm happy today to present some results of a project I worked when I was a postdoc at Clémence University, and it was a big project that was funded to research Twitchett by the NERC. So we heard about the early Toarcian extinction event early before. We know that the Palaeontological interval of the early Jurassic has been a period of intensive environmental changes, very strong in the Mesozoic. It was probably triggered by the intrusion of the Carboniferous Larginus province and the related volcanisms. And we know that this triggered a strong carbon cycle perturbation. It was a period of global warming, sea level rise, and in many areas, both in the Pantalassa and in the Tethys, a lot of black shale deposition, of course. And so this event is also related to the extinction event, not one of the big five, but it is considered a second order extinction event. So this was mostly studied as event is in the northwestern Tethys, and especially in the northern part, for instance, in the Cleveland Basin. And in this kind of basin, they are restricted basins, and so the Toarcian event coincides with intense black shales. And so the event has been always so far related to anoxia. So anoxia has been considered the main cause of extinction. However, in recent years, other people studied other area in Danise, and they found that extinction is also found in more oxygenated phases, So what we wanted to do it was to understand, the question was, is it possible to understand what other factors control marine benthic community change through the Toarcian event in the absence of anoxia and black shale deposition. So I like to work in Yorkshire, but Spain I think is a nice place as well, much more sunnier. So we went to Spain, especially in the Iberian range, in the northeastern part of Spain. And so why it is nice? Because in the early Jurassic, this place was a shallow, it was a carbonate ramp that was deepening gently toward the north. So we didn't choose just one section for our study, but we chose two. One that is called Sierra Palomera, that is to the south, so it would be our shallower section, and the other one more to the north, Castrovido, that is our deeper section, and they are around 300 kilometers apart. So what we wanted to do it was to compare the response of benthic community to the Toarcian event along an onshore-offshore gradient to see if there was a difference in these two deep water settings. And also we wanted to compare the response of two benthic groups, bivalves and brachiopods, because they were the most abundant groups, and brachiopods at that time, they were very abundant still in the Jurassic in shallow waters. So what did we do? Okay, we collected for our fossil data bulk samples that were around 3 kilos each. So we had these, we could build in the lab this data set at the species level. And then we also wanted to characterize the environmental change through time. And so we did some geochemistry. It's not a very fancy geochemistry, but we sampled every 10 centimeters the bulk rock throughout the sections. And so we have total organic carbon analysis. And then on the bulk rock as well, we had oxygen and carbon isotope data. And then from the belemnites and the brachiopods that we found throughout the section, we also did the carbon and oxygen isotope data. So this is one of the sections, the deeper water section. It's not a black shale at all. So here you have the upper part of the section. So the lower part is a bioclastic Paxton and Wakestone, but then here you have this upper part when you have an alternation on limestone and marls. Other authors before had also looked at the sequence stratigraphic surfaces and recognized transgressive and regressive cycles, so sea level changes through the section that are very easy to see also in the field. So we also look at these to see if there was any stratigraphic control on the fossil, on the patterns on our fossils that we were looking at. So this is the result. This is just how our brachiopods and bivalves occur throughout the section. So there are three things that we have to look in this graph. Okay, so just with the highs, it's very easy to see that brachiopods and bivalves do quite different things, because if you look, here you've got this transgressive surface, and you see that there is the last occurrence of most of all the brachiopods that were in the plains Bacchian and in the lower part of the Toarcian. Then there is this interval of about 1 meter that is empty of fossils. We didn't find any fossils there. And then we start to have the occurrences of the few brachiopods that enter into the basin that we find into the section. But what do the bivalves do? They do slightly different things. Some of them have the last occurrence of these surfaces, but many of them, they just go through the interval. So it looks like maybe brachiopods were more affected by this event, environmental change, than the bivalves. Then if we look who is coming back soon after this interval, there are two species that are highlighted in orange that are very abundant. One is the brachiopods, Toarcian bouchardi, and the other one is the pectinid bivalves, Parvamusum cumilium. So what are their characteristics? If you look at them, what they are very tiny, smooth bivalves. They're very plastic, and usually you see they are like around 1 centimeter in size. And they've been usually interpreted as opportunistic taxa that would enter into the basin and colonize the basin, colonizing the ecospace that was vacated during the extinction. And this is an interpretation. But if you look at this, here you've got a big transgression, so you are shallower and you become very abruptly, you become deeper. So you've got the last occurrences of this taxa, and here is deeper water. So another interpretation could just be that these species are just happier in deeper water. And so then when the environment starts to shallow again, then they go away and the new species come into. So this is another interpretation. And usually, so Toarcian as a genus in the Triassic is found in deep water settings. So, but what about the Geochemist? So here there are two things that we can look at. So this line is the last occurrences of the, let's say, plains Bacchian early Toarcian brachiopods. So we've got high peak of total organic carbon soon after this, and the semistratum elegantonum transition. And then if we look at the record of the belemnite and the brachiopods, oxygen isotopes, the value become more negative going up into the section. So what do we record is that it is a warming throughout the event. Of course, considering salinity constant throughout the event. And then we can also add some information about how our community changed through time, looking at changes in richness, evenness, and also at the first axis of the ordination to look at community level change. Here, for instance, different color are different biophases, and you see that the color changed through time because our community changed through time. And so, of course, you've got a negative value, which is soon after the last occurrences, corresponding to a peak of TOC, but then diversity values are very high throughout the section. All the sections are very bioturbated throughout. Then we can go to the second section, the more shallow water one. And here there are some patterns that are similar, and some are very different. So if you look at the brachiopods as well, there are these last occurrences, and then there is a complete turnover of brachiopods, such as that's the same, very similar pattern than the deeper water section. If you look at the bivalves, again, you've got that some stop somewhere here, but some others, there are many that go through the interval. And also, if you look at the number of species, this is much more diverse, and this is, I mean, it's not surprising because we are in shallower sections, and we would consider having like a higher diversity. But if you look at where is the last occurrences of our brachiopods up here, before it was the transgressive surfaces, but this is another stratigraphic surfaces. This is the maximum flooding surface. So again, like the way that in two different sections the communities behave, it is slightly different. Then, if we look at the Geochemist, it's not the same. I mean, if we look at the carbon and at the oxygen isotopes, we see a nice trend toward more negative values. So we see the same trend of warming throughout the event. However, the TOC values are very different. Before we just had a peak of TOC here, while here we can see the TOC values are much higher. They are sometimes you get to 5%, and as well, but the peak is very high. So we were kind of puzzled by these results. We couldn't understand them, but then we found this study made on the same section, but some Baron et al. In 1999, and we're looking at the microfossils. And they found that at this level, there is a big change in the composition. So they have plankton primary producer, they disappear, and then all the content of their samples is just terrestrially derived palynomorphs. So probably this high peak of TOC are just the influx of total organic carbon, into the system, not from the marine primary producer, but from land. And this makes sense because this is a shallower water section, so the section is closer to the land. So this peak of TOC are probably linked to increased runoff, and this makes sense considering that it is a period of warming. And again, now if we look at the richness, evenness, and community change through time, it was evident that we have a correspondence between high TOC values with low richness and low TOC value with high richness. So the last thing that we did with this data, it was just to make simple Spearman-Grant correlations and to see if it was possible to correlate the changes in the environment with the three measures that we had, changes in TOC, in delta 13C and delta 18O from the benthic, so from the brachiopods, and the benthic variables, so richness, evenness, and community change. And what we found, it was that the two different localities community responded in a different way. So in the different section, community changes correlates with changes in delta 18O. So probably temperature had an influence on community change through the Toarcian extinction event. While in the shallower section, changes in richness and evenness correlate with TOC change, indicated variation in nutrient input, probably from runoff, correlated to fauna diversity. So, to conclude, what is important to say about this data? So we found different response of the two benthic groups, bivalves and brachiopods, that there were brachiopods more affected by the extinction probably. Also, stratigraphic patterns varies between the two localities. And the response to environmental parameters that we have measured, we have just three, but in these three we found different correlations. So why this is important? It is important because we always need to consider local sedimentary stratigraphic processes that are controlling the shape both of the geochemical and the fossil record, and so we need to study multiple sections along onshore, offshore gradients before we can do any extrapolation about regional and global patterns. And with this, I finish. Thank you.